Hey guys, welcome to Math Spellbook. I'm your host Peter, and basically we are going to get back to, I guess, doing some of the basics today. Just basically doing multivariable calculus, because I haven't been doing much calculation-based, I guess, like calculation-based math so far. So I feel like I should just get back into doing that just before I forget, like, you know, what a derivative is or what an integral is. I know I won't forget what those are, but at the same time, it's like the techniques, sometimes if you don't do them for too long, they end up not coming through. So some stuff I'll be doing through the Udemy website. So I have my browser audio like muted for you guys, because on Udemy it's sort of like you pay for a course, and I don't want to put like too much of the originator's content onto the stream. So I'll basically be writing notes whenever I look up stuff from there. So because I usually do like at least like one section every morning, just so I can I started doing this like recently, because I feel like I've been slacking on this on just basically doing like calculation based math. So you guys will witness my notes as I like write down stuff. So oops, why did it do that? Okay, so in this section we'll be doing parallel intersecting and perpendicular lines. So I'm guessing, because like for the first couple of sections that I did, we were doing like basically the symmetric equation, the parametric equation for vectors, and the vector equation for, I think like lines in general. So now I think we're going to get into, like, you know, where things like cross. So I'm just basically reading through the notes, and I'm not putting the notes up in front for obvious reasons, because this is from the original creators' stuff, so I don't want to like put their stuff on, you know, without their permission. So I'm just basically trying to like read stuff, and then basically I'm gonna try to summarize in my own words. And actually it's good practice for me too, because it's like it allows me to solidify the knowledge in a way that makes sense to me, and hopefully when it makes sense to me I can write it down in a way that only well, I wouldn't say only I, but like basically someone probably can look over my notes and see what I'm thinking in my own head. They do have something called skewed line, but I don't think that's a test. I think it's just basically like once every option is used up. So according to the parallel line test, like the way they have it is like, so R naught is basically the original point we started with, and we have t and the vector here. So according to them, a line is and a vector. Let's just write down the vector is components. Let's just make it let's make it A, B, C here. And if we have two lines, let's just make this R1 and R2. I'll put that V1. Put a little 1 here and a little 2 here. R0 set. And then I think for V1, 2, we'll put E, D, and F here. Just to differentiate between the two. So according to what, just put line 1 here, and then line 2. Because if we have two lines, if they're parallel, then basically according to so basically you have to take the components of the vector and hopefully they're symmetric with the others, so because apparently I think the symmetric equation basically gives this relationship. So I think we can write symmetric equation just to keep that in mind. Oh, you guys can't see that. So just move that over there. Okay, so for perpendicular or intersecting, so basically I think for perpendicular test, you just have to do the dot product of the lines. And then if it equals 0, then they're perpendicular to each other, which is probably a given. So according to this, if the line is skewed, then not parallel and not intersecting. So now they give us an example. Over their example. I'm not writing in my notes because, like, for obvious reasons. So, let's see. So I'm guessing in this section we have to determine what type of line it is, or what type of relationship two lines share, whether they be parallel, intersecting, perpendicular, or skewed. guess like according to like the notes they have here, it's like when you're trying to do like to see when you know it's not parallel, you have to be careful because if the dot product is not 0, that doesn't mean that they're not intersecting. It just means they're not intersecting on a 90 degrees. So that's probably good to know. Okay, so for the first question, now we have to actually figure this stuff out. So they're definitely not parallel, so now we go on to our next step, just basically seeing if they intersect. So let's just, so not parallel. That's probably the first test I think you should I think we should do because it's the simplest. Now let's see if they intersect. So we have to set each of them accordingly to each other by their components. Hey Sasha. Alright, so I guess we're gonna have to solve for t because t looks like it's either t or s. So I mean we can assign both of them seem valid. Let's solve for t because that's the first line. So for t we'll let t equal 3 minus s minus 1, which leaves t to be 2 minus s. Okay, so I guess we'll do that to the one that we altered. So t is s minus 2, and then, well, how's it going, Sasha? What's going on your side of the world? Now we have, oh. I mean, maybe that was a bad idea. Maybe we should test it on another equation. Okay, so we have two, so let's do it on the first one. So that way we can at least get s equal to something. So we have -2. So let's add 2s on both sides. I'll bring this up so you guys can see it better. That would be -1, positive s, and then 2 on this side, and then +1. So s is equal to 3. So now that s is equal to 3, now we can just solve these two. No, I feel like I'm doing this with the wrong approach. Because it's supposed to be solved as a system of equations. So I think I have to write this. I mean, like, the first step we did was that we made t equal basically 2 minus s, which I think we could do. Now the thing is that have you considered getting into programming? Honestly, like, I don't mind learning to code. It's just that for me, sitting and programming things, it just feels like, I think I tried like taking like a C+ course. Was it C++? Yeah, I think it was C++, and like I kind of got bored when I was just sitting there just trying to like figure out how a code works. I feel like you would be good at it. Honestly, the thing of it is that I haven't found anything that interested in me in programming that much. Maybe I haven't found the right project. I'm not taking it out of possibility, but at the same time, it's like, for me, it's like, I honestly felt like I kind of like don't really have focus when it comes to coding. Because like when I try to learn like coding languages, I end up going okay by the first couple of days, but then I end up like going on to something else. It's not like math where it's basically in the back of my, it's like on my shoulders, and basically it's like, oh, you haven't solved any math problems today, or you haven't picked up any math books and read them. It's not like that. It's not like I have an itch. It's like with physics and math, I feel like I always have an itch where it's like, I feel like I have to do at least something math related once a day. With physics, it feels like I would have to read something about physics mainly. Math, I would have to like read something on a definition, or maybe like do a math problem or something, which is why I do it in the morning. But how you doing, Famish? How you doing? What makes you think that I would be pretty good at programming? Because I've never gotten that comment before, which I appreciate, because I'm like, oh, okay. I never thought of myself as someone that could probably be decent at that. just playing. I'm just playing with the math practically. This is why I invested in another monitor, so I can learn programming while having a show in the background to keep my sanity. I'm okay with math. I don't think I'm good at it. Not yet. Famish, I feel like you know more math than me, though. It's the funny reason I heard to get a second monitor. No, I mean, I believe it, actually, because I think people that deal with programming or do anything with computers, like, they'd rather have something in the background that keeps them focused on work. And usually the only way to be focused on work is not to have your not have your mind on the work 100%. Or have something in the background that makes you feel like you're not working as hard. I mean, that's what I think. Because I think that explains why so many programmers have, like, so many things playing in the background, because they want to have, like, music playing or, like, a movie playing, so it feels like they're not trapped in the office. I don't listen to music much. That's fair. But I heard some programmers do that. Like, they have music playing in the background. So it's like, it's like probably one of their processes, or processes, I should say. Yeah, maybe I'm not doing this right. Because I think we're gonna have to do the linear algebra approach, where it's like we have like multiple variables. So, plus 2s that equals 2, and then plus 2, and minus s, which equals 2. Then we have 1t plus s is equal to 3. Okay. Now, we gotta have to eliminate one of them. So we'll just have s equal to 3 minus 1 minus t. Okay. Now we'll move this over here. So t plus 2 times... Oh, oops. Forgot to do this. There we go. That makes it easier. So 2... Oops. Too close. So 2 minus t times 2 equals 2. Then we'll have 4 minus 2t. Then 2. And then basically does... actually, I don't need to write that 1 here. So it'll be 5. And then minus 3 equals 2. So if t is equal to 1 in this case, then that means we have 1 plus 1 plus s equals 3. And we have 2. So then s is also equal to 1. So therefore, let's see if it works. So 1 minus 1 plus 2 equals 2. Yeah, that works for the first one. The second one is 1 plus 2 minus 1. Yeah, that's also 2. Okay, that works. 1 plus 1 plus 1 equals 3. Okay, so they all work. And I feel like I'm not doing the right procedure. Because I realized that we have to show that because the original point of this question is to see if they're perpendicular or they're intersecting. And if not, then they're skewed lines. But I did the linear algebra thing where it's like with the system of equations. I mean, we did find that s and 1 give us all the variables we need, so I think that means they do intersect then, in that case. Because they intersected both when s is 1 and t is 1. Background shows is what the category is called. Can range from medical shows or education shows in general to stuff like Futurama. That's fair. That's fair. So they do intersect, I think. Now the question is that are they perpendicular to one another? And I think we can do that through their vectors, I think. If we take the cross product of their vectors. So the one thing we know is that they intersect. Now, because the choices we have is either they're parallel, they intersecting, or intersecting in parallel, or skewed. Or skew, I should say. So we know that they intersect. Now, the question is that are they perpendicular? And I think we have to use their vectors to see if they're perpendicular to each other and get the dot product of those two. So they intersect. So that's a given. Now we just have to see if they're perpendicular to each other. If not, then we already know their answer. So this one is vectors -1, +2, and 1. And we have the vector -2, 1, and -1. So if we do the dot product of these, if we get 0, then they're perpendicular. If not, then we don't. Then they just intersect. So this equals 2. This equals 2. This equals -1. So it comes out to be 3. So that means I think they intersect. So let's see if we're correct in this case. If not, then we did it completely wrong. Or maybe we just got like a step wrong. So check answer. Hey, we get it correct. We got it correct. Nice. Okay, next question. Okay, at least it helped me warmed up my linear algebra muscles. Because it allowed me to like actually remember stuff. Like if we have the same if we have an intersection, basically we're gonna get like everything correct for like these. It allowed me to remember that part of the definition, and I was like, oh wait, I remember this. Okay, so we have the line. So line 1 in this scenario. This is number 2. There's like 2 questions to every quiz, so x1 is 3 plus 4, and then y negative 2 plus 3, z1 minus 1. Actually, Famish, are you a programmer? Since you asked the question. Because I feel like you do work with computers, I just don't remember what it was. I'm gonna erase that 4 because it almost looked like a 9 to me. Okay, now time to do the old symmetric test. I think we got our answer. Because they do look like they reduce to one another. Yep, they do, so I think it's parallel. Let me re-look at the numbers just in case. I don't want to mix things up. They look like they match. So let's see if we're right. Yep, we are correct. Nice, they're all parallel. That one was a quick one. That's good. Okay, so this one we have line 1. Actually, like one of my nephews, he's taking pre-calculus, but he hasn't asked me for help. But he's really smart, so I don't think he needs my help. He was just so excited to tell me that he was doing pre-calc for the summer. Because he kind of hinted at me that he said he might ask me for help, but at the same time, I don't feel like he needs my help because he hasn't asked me anything yet. This pre-calc is a very dense subject. It's just a lot to take in. Actually, like when I was trying to do school for engineering, I tried to take linear algebra and multivariable calculus at the same time, but I ended up taking linear algebra over the summer, and it was an online course, so it was much easier for me to do that. But at the same time, it was kind of unfortunate that I couldn't like combine the subjects so I can actually like utilize them in a more versatile way. But then again, I guess with multivariable calculus, you do learn a little bit of linear algebra on the way. It's just kind of unfortunate that you don't mix a little bit of matrices that much. I mean, you do use. I think in multivariable calculus you can use determinants, but they don't really go into matrices that much until you get into like the Jacobian, I think. But then again, you can also use the Jacobian in linear algebra. It just feels like they cross together a lot. Okay, so let's see if they're parallel first. So we have -3 over -4. Then we have 5 over 4. Then we have 1 over 4. So I don't think these, yep, they don't look like they match. So it's definitely not parallel. So now we gotta do the hard part, which is combining them all. What fun. Actually, I think the thing I like about math is like when you actually like just write a lot of stuff and you like start messing around with stuff and then you're like, oh wait, this works. Okay, so let's just change it into a series of equations we can have fun with. So +4 equals 2. And this one, it will be -3 plus 5t. And then we'll put -4s. And equals 6. And then 4 plus t minus 8s is equal to 3. Okay. I mean, if we do the first two, like the first two equations, the 4's cancel, the s's cancel each other out. So maybe we can mess with that one. Let's go down here. I think I'm in my mind, I'm probably doing something I think is clever, but it probably isn't. So I could end up like screwing everything up at this point. So, because let's see, we are left with -2 here, and then at this point we're left with +2, and then equal to 10, and then that equals 5. So t is equal to 5, so let's see if it works out. So in this case, if t is equal to 5, then s, then we live with 9. 9 minus, that leaves us with 6. -6 actually. And s is equal to 3/4. Let me see, did I do the arithmetic right? Just want to double check, just to ensure that I didn't miss anything. Because that's the one thing about like calculation-based math, you have to actually look at the numbers you're dealing with. And I do have my calculator with me. So let's just see if it works. So if this is 5, I get a feeling it's supposed to be equal to 2, so, but then this is 15, and +3, yeah, that doesn't look like it works. Yeah, because then we combine this to be, yeah, that would be just like 4. And that will leave us with -11 is equal to 2. Let me just double check to make sure we did everything correctly. This was something I never really did in elementary school because I was just like, I just wanted to get the problem done. But I have the time, so I might as well just check it just in case. And I make mistakes on the stream, or in the videos is a lot, but I post them up on YouTube anyway, so you guys can see what I'm doing. And hopefully you don't make the same mistakes I'm doing. That's not... Everything looks fine. So if it doesn't match, so let's check the other ones. Maybe... Because like if you do it with this... Supposed to be 6 here, so 325. Output equal to 6. 6 minus 25. Yeah, that's not going to get a 6, so that doesn't work. So I'm thinking this line is skewed because it doesn't seem like it intersects. Let's see if I might be wrong in this one, but let's just check. Oh, we are correct. Okay, it is skewed. Okay, so I guess we did it correctly. Okay. All right. That's good. That's good. So we got all 3 questions correct. Cool. So now the next part is the equation of a plane. Ooh, this one should be fun. I'm not being sarcastic with that. It's just that sometimes like with the higher stuff, like you have to like do more math and you're like, oh wow, this is a lot more to do. But you know, that's why we love it. So the equation of a plane. I'm just gonna write the general form, because usually the general form is always important when you're doing math, especially with differential equations. When you remember the differential, when you remember the form, the general form, it makes it like so much easier to like work out problems. Equals 0. Okay. Oh, hello. Marissa? Martha. For some reason, I keep thinking Methuselah when I was reading it. Grandma Ursula. Oh, okay. Yeah, I was trying to read it, but then like I didn't see the the ma and grandma for a second. Grandma Ursula. Okay. Sorry for mispronouncing it. Are you in college or teaching? Neither. Neither. I'm just trying to like learn math on my own. But welcome in, Grandma Ursula. Hopefully I'm pronouncing it correctly. Your name. But what's the best part of your day so far? All good. I ain't no grandmother either. Just thought it was funny. A funny name. Yeah, that's fine. I'm just basically learning math on my own. Right now I'm just covering multivariable calculus on my own. Because I've been working on mathematical proofs like in the entirety of my stream so far, and I feel like I should just get back to the basics. Oh, just wrote my electrodynamics exam and I'm chilling right now. Oh, okay. Do you teach? Or did you just take an exam like online? Oh, you're studying physics at uni. Okay. Yeah, I had I really want to study physics as well, but I barely know the basics. I think like the thing with physics is that I remember the equations, but I don't remember how to use them in the correct way when it comes to problems. So I actually have to practice on physics a lot more. If you need some help, I happen to know something, feel free to ask. Oh, thank you. Thank you for that offer. I appreciate it. I actually want to like learn math and physics conjointly. So it's like I want to learn enough math to understand physics, but at the same time I also want I guess I want to learn more math so I can actually incorporate into physics ideas. Which is why I'm studying both proof-based math and regular math. I mean, calculation-based math at the same time. I guess I just want to understand physics in a mathematical way, but at the same time, I also want to be able to enhance mathematical knowledge through a physical way. It's a bit of a contradictory type of process. You gotta know your math, so of physics, it's literally just math. I would agree with you, but at the same time, I think, like, experimentalists would beg to differ. Because, like, I guess when you get to higher maths, like, they feel like, oh, it's just theorists just basically just incorporating mathematical ideas into physical processes we can't observe yet. Like in theoretical physics, you have like one or two experimentally derived results. The rest is structural analysis. Yeah, because like right now I'm also trying to teach myself real analysis, and that's not going very well. It's not going very well. I'm not taking a class on it or anything. I'm just trying to teach myself how to do mathematical proofs, and it's not easy. I like whenever I do it on stream, I get very flustered because it's just me just staring at a blank canvas the whole time. And when I mean canvas, I mean the writing program I'm using. Well, not writing program, but the writing browser program I'm using. So far, the math that I know is like scattered. So I know Calc 1. I have scattered memory of Calc 2 because I barely remember the integration techniques, as well as I do remember the series test, but at the same time I haven't done problems with them in a long time. And I have a little bit of knowledge about multivariable, but at the same time I don't know the technicals, so this is why I'm doing multivariable right now. And for differential equations, I think I got up to like Bernoulli, but I still have to like actually like practice more because I haven't done second order linear differential equations. So, but I know what a partial derivative is. I know what I have read up on like what curl is and what divergence is, and the Laplacian. So yeah, like my knowledge of math is very scattered because I've read like different math books of different time periods. I haven't taken like formal classes in like multivariable calculus or differential equations. So yeah, hopefully that answers your question. So let's see where it is. So A, B, and C. It's a normal vector. If that stuff interests you, go into differential equations, but first, by first getting a grasp of differential forms. Makes the whole subject make way more sense, I feel. Oh, okay. I don't want to distract you, though. I'm just watching. Oh no, it's fine. It's fine. Like, you know, like if like. Even though I am quote unquote trying to like learn more, like don't think of it like when you talk to me in chat, don't think of it as me just being distracted. It's just that think of it as sort of like I'm doing my own little mathematical research and you're just like talking to me to like, you know, like because like the work you're doing is just too easy for you in your cubicle. I usually think of it that way. It's like basically we're just chilling in the same room and I'm just basically doing my project and you're doing yours. That's usually how I think of my streams. Even though they're kind of like study streams, they're kind of really not really, in a way, if you get what I mean. Given 3 points on the plane. So the way they wrote this. So I'm guessing these are points. So they have. So let's just erase this for a second. Because they have points, that is point P, which is 2. Oops, not Q. We're not into Q yet. Oh, thank you for the follow, Grandma Ursula. Yeah, I just usually think of it as sort of like me doing, like, think of it as sort of like, you know, when you're at your friend's house and your friend is doing one thing, but you guys are like, just in the same room together. So let's say like say you're on like your friend's bed and just basically just playing on your phone while they're doing, maybe a painting and you guys are just talking. I usually think of it that way. It's like, let's talk about the thing, you guys are just probably talking about life while they're working on something on the other side. I usually think of it that way. Yeah, joint study session. Yeah, something like that, yeah. Because I want my streams to be a little bit loose. Not like a really stuffy stream where it's like, oh, we're gonna do hardcore studying for like 8 hours. I don't know how people do that. Like for me, I barely am able to study for 45 minutes. And that's only when I'm in the real groove of the study. Usually I end up studying for like maybe like half an hour. Maybe I should just bring this over here. Okay, oops, no, that's not, I don't want that. And Ursula, if you wanna like, if you wanna join our Discord server, you're more than happy to join our Discord server. Just like type in !Discord, and it should give you access to the link to the Discord. I have to be more active on it though. I haven't been active on it lately. But that's like basically where we can like, cause like I think for me it's like I want to learn like higher math, like basically math in higher branches, but I want to be able to learn it through physics. I probably am like someone that doesn't want to go into too much in the formalism. But maybe there's no other way around it though. Yeah. Yeah, I'm using the 3 blue 1 brown music. It's the best way for me to like actually get music to study with. Because apparently the composer, he allows you to use your his music for content as long as you like get permission first. Because I think he allows people to like use it. What interests you most in physics? What do you want to understand? Unfortunately, I'm like one of those typical like physics hobbyists that get into physics because of the theoretical stuff. So like anything from like, you know, like I guess like, yeah, I do like string theory, I do like quantum gravity, but I also like the questions outside of those, like cosmology and inflation and all that stuff. Because honestly, like if I was able to like capably work in physics, obviously I'm not, because I'm not in grad school or anything, because obviously I'm not there. But if I did like wanted to work in like physics, like for math, I would have to say I would like to work in mathematical physics. But if I was working in physics, I would probably want to work in cosmology. I think that's basically where I think my focus would be in. If I were to, like, you know, go back to school and, like, basically, like, do physics as a living, as a career. way more than math hobbyists already actually doing the work to understand it. Well, I'm trying. The thing of it is that like I barely pick up a physics textbook to do problems. I think like I do more math problems than physics problems. I like so done with school. Yeah, it's too expensive. I agree. That's the reason why I'm not in university. Like, actually, like, I mean, I did go to university for an English major because, like, obviously my parents were like, you gotta go to school. And I was like, I don't want to take exams. I don't want to do typical schoolwork. So I was an English major because they just let me write essays. Every class that basically I went to, like, if they had an exam or a test, I instantly dropped it because I was like, no, I'm an English major and I just want to do essays. I don't want to do tests because with essays I can just write it like within one night and I would get a B and I would be like, okay, I did that, I pass. Although I did not challenge myself, which is probably a bad thing. I rather enjoy the knowledge and build something out of it and use it. Yeah, I agree. That's the reason why we learn in the first place. Oh, you said something, Grandma Ursula. What did you say? Because physics is math, every modern theory is just pushing maths to do its very limit and seeing what structure emerges. Yeah, I think like with physics, you have to think of physics as sort of like you're building axioms to the universe, and the problem is that the building of the axioms is not complete. So, so the problem is that the mathematical structure is not complete, which is probably why you can't have mathematical proofs in physics, because like the study of the universe is still incomplete. Because I think with math, like with each branch, there's like I don't know, like for anyone that's in pure maths, right? When you do a branch of math, is the axioms considered like, I guess, like the final structure of the subject before you actually can do proofs in them? Because I feel like with branches of math, you have to have like a certain amount of axioms that basically help you guide you to actually come up with proofs in the subject. It's like when you think of geometry, you actually have to have a plane, while in, I guess in number theory, you don't need one, you just have to have the number line. Like studied how to solve an electric field based on charge distribution, and I ended up learning how to represent certain symmetry groups on surface. Oh, that sounds very interesting. Yeah, I'm interested in like math like that when it talks about symmetries and group theory and rings and all that stuff. Well, I think basically in physics it's more like fields and group theory. I mean groups, I should say. Actually, like Grandma Ursula, like what is it that you do? Because it seems like you're really high in the subject. If you don't want to reveal what you do for a living, that's fine. Just let me know, and I won't ask anymore. Because I think what I like about my math streams is that I'm able to connect with people like you guys, because all of you guys come from different walks of life. Some of you are already working, and some of you guys are in, you're in a graduate school, and some of you, like Sasha, who were nice enough to actually teach me some things about, like, I guess, proof-based math. So, you know, I feel like I'm learning a lot of stuff from you guys every day. Or every stream, I should say. Because it kind of inspires me to pick up the book and just start reading. But at the same time, I don't do problems enough. Which I probably should do. Because I'm trying to, like, for me, the reason why I started learning physics and mathematics is because I want to write a fiction book that kind of uses math as sort of like a spellcasting tool. Like, you know how, like, in magic, like, when you see, like, in fantasy shows or movies, they would have, like, weird, like, hieroglyphs or, like, scriptures, like, in front of them, and they would cast a spell, and then the spell would activate. I think of math that way. But the thing of it is that I'm not higher up in, like, I guess my math knowledge to actually be able to write mathematical equations for the main characters to use to alter certain physical phenomenon. I'm a grad physics student. Oh, cool. So what is your field of study then, if you're a grad student? Are you doing your PhD or your master's? So we gotta do the cross product with this. So we have the normal vector, so PQ. So I'm guessing we're supposed to get this to get to do this to get the normal vector here, because the cross product is supposed to be the normal vector that either goes perpendicular to both vectors. So I think that's why we have to do the cross product here. And I think we already know what this is. I don't have to write the whole thing here. They give us an example. Okay, so I'm guessing every problem is going to give us points, and we're supposed to figure out what the normal vector is to write the equation of the plane. All right, let's see if we can. I've done most of these problems already, but I'm retrying quizzes so I can actually get back, because I think the thing I stopped at in this part was, I think I got lost when they were talking about limits. When they were talking about limits of multivariable functions, and I think because I didn't do what do you call it? I didn't do epsilon and delta limits for Calc 1. I think that's when I got lost. So masters, okay. Like, what are you researching? Are you researching like electromagnetism? Are you studying anything like related to like quantum mechanics? Like, what is your what is your research dedicated to? If you're willing to share that. I'm just doing courses. Oh, really? Okay. I thought you actually had to have like research like in the back of your mind when you start a master's, but maybe I'm just overestimating grad school, because I think grad school we always think of research, but we don't think of anything else. I mean, what courses interest you so far, though? I think I should start with that then. Actually, like for me, like I think when I'm doing like regular like calculation-based math, I really want to get into tensors, because I know physics really uses tensors a lot, but I still don't fully understand how to use them. I don't know. I'm in Austria. Maybe it's different here. I got to do my master's thesis someday, though. Yeah, I think it's because for me, I usually think of grad school as just people that go do research on something, but I always forget that you also have to take classes while you're doing that. I mean, obviously you should take classes, but at the same time, I always forget that. I usually think that when you go to grad school, I always think that it's just mainly students doing research. Yeah, tensors took me a while to grasp. Yeah, because I know, like, the idea I think of with tensors is that you have to think of it as sort of like you're on a bridge, and when the bridge wobbles, like, you have to think of like the tensor as sort of like how's a good way to describe it? Because I had it in my head. Like you have to think of like the tensor as sort of like the areas of space where the bridge is shaking, and when the bridge shakes, like the tensor is like, depending upon the way the coordinate system is structured, you have to have like the tensor, like, I think, change as the bridge continues to shake, if that makes any sense. I know there was an engineering example that was using bridges, but now I completely forgot the metaphor that I had in my head. That's where I get stuck on. I know about them, but I still don't fully grasp on them yet. I know, like, basically one, like, when one stretches, the other shrinks. So, and, like, they have this sort of versatile relationship, like, you know how, potential energy is sort of, like, depletes while kinetic energy increases? I know they have that sort of relationship. And if I say something that's completely out of context, like, let me know, guys, because sometimes I feel like I know ideas from physics and mathematics, but then I could probably, like, misrepresent it because of the limited knowledge I have. So, you know, correct me whenever I get I guess a comparison or a metaphor wrong in this case. And a plane. Oops, that is too smudged. Would be a nice foundation to build up the intuition on tensors. Yeah, like, I get a little bit mixed up with them because I feel like I'm closer to understanding what they are. It's just that, like, I know, like, covariant, you have, I think that is the, let's see, covariant. Covariant is the subscript, and quadravariant is the, superscript. Because I know they're supposed to represent the same thing. It's just that I think you're supposed to conjoin quadravariant was it coefficients with quadravariant vector components, or is it the other way around? Like I know you mix them up when you write them in, like, I guess equation form. Like, now I'm trying to remember exactly what I learned from those topics. Okay, find the point where the lines intersect in the plane. Okay, so we have a line that has, okay, so its original points are 0, 1, and we have 4, so I'm guessing it was probably like 0 on the vector, so I think plus t times -1, 2, and 0. I think that's the original line equation there. Okay, we got the plane, which is just basically, so the direction, the normal vector in this one is 1, 1, 1, so I'll just write plane end here. Imagine you sit in front of a table with a grid on it, like a coordinate system, then you hang an arrow over it, okay? Maybe we can draw it. So let's just pretend this is a coordinate system. Boom, 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 boom. And then you hang an arrow over it. What happens when you turn the table, transform the coordinate system? Well, the point of view of the arrow, you turn the table to the left. From the point of view of the table, the arrow turns to the right. But the arrow itself stays in space. Its position should not change if you turn the table. Okay. So yeah, that's the perspective. That's co and quadravariant. So which represents the covariant, and which one represents the quadravariant? Because I know, like, with the shifting of the table and the arrow's perspective of the table, I know that has some sort of relationship with the quadrivariant and the covariant metaphor here. I mean, it's a good visual to think about, though. Let's see, the coordinate system has to transform in the opposite direction to the coordinates of the vector. So the position of the arrow in space stays the same. Okay, so the arrow stays in its place while the I guess the grid, the table, as it were, moves in a different direction. So like say if we move the table to the right, then the arrow, and from the, I guess we'll put from the table's perspective, the arrow is to the left, and from the arrow's perspective, the table is moving to the right. You have a vector and you describe it by unit vectors components. If you transform the coordinate system, the unit vectors, you have to change the coordinate system, the coordinates as well, but in the opposite direction, so that the result, the vector stays the same. Okay. Yeah, because I know tensors, they're supposed to make sure that the way space is, it doesn't really. I guess it helps bring the components back to the way they were. Or, you know, or to the new system in some ways. Because I know tensors, they're supposed to make it so that space and the change of coordinates don't alter the final result. Okay, so find the point where the line intersects the plane. So I think we're gonna have to do the cross product of the vectors here. So, oh, this is going to be the one thing about the cross product is we gotta do this. If anyone that does the cross product knows how to do this without writing this, I give them so much props, because I'm like, dang, like I have to have this every single time I do the cross product. Okay, so the first one, I think it's supposed to be y, and so y and z. That's gonna be I, and then the next one plus. I know like some people put minus, but I try to do it like with plus because it's so much easier to memorize for me. And then because whenever I put minus, I'm like, oh my god, I have to switch it around all over again, and that is like a nightmare. Okay. Okay. So the final result, we get 2i plus j. -1 minus, so this is going to be -3. So find the point where the lines intersect the plane. Let's see. Oh, yeah, you typed something, Grandma Ursula, like what you typed. Sorry if I confused you even more. No, it's fine. I feel like the more I look at like the way people describe it or the way I read it in a book, I feel like I'm getting closer to actually understanding exactly what is it trying to do. I know with quadravariant and covariant components, they have to deal with the different perspectives, like you said. Like, you know, if you're thinking about the arrow's perspective, the table's moving to the right, while the table's perspective, the arrow's moving to the left. But in actuality, the tensor is supposed to describe the whole entire room that the change is occurring in. So the way I remember it, the way I kind of like remember the way the equations are set up is that you have to have, I think, like something of the, you have to have the vector of the covariant, but then you have to have unit vectors of the quadravariant with it. Because I know you're supposed to crisscross them in some way. Like when you're writing them in a mathematical way. I don't know if that's correct, but that's what I remember from the book. Because I know you're supposed to mix up, I think, like maybe vector components from one system, but then you have to put the unit vectors of another. Okay, so find the point where the lines intersect. Okay. So we got the vector. Now we just have to figure out how does that relate to the intersection of the line and the plane. Because we got the, now we got the normal vector that basically comes out of both the plane and the line. Now we have to actually find the point where they intersect the plane and the line. Let's see. Maybe we have to put like the components of the line into the plane equation. Maybe that might work. Because maybe we can solve for t, and maybe t will be given to us, and then we'll get the components we need. So we have regular t, and then 2 plus 1, 1 plus 4, that's 5, and then we have 5 here, and then 5 minus, that's negative 1. Oops. Yeah, so I want to make sure I did my arithmetic correctly here. So if we have negative 1 in this case, then so if x is negative 1, then x is 1, then y would be negative 1, so that would be negative 1. And then z would just be 4, because there's no t there. And it does look like we have those choices in the answers. So hopefully I'm right. So check answer. Yes, we're correct. Okay, nice. Okay, so I guess my thinking was not wrong in that. Okay, because I was thinking like Oh, great. Now I have to think about how to intersect the line. like I have to think about the intersection point. But we managed to figure it out. Okay, next one. Next problem. Yeah, that took me a bit because I think like when I did multivariable calculus, or at least like tried to do it, the intersection of points and planes and lines, those are the ones that kind of got me a little bit of trouble. Intersects the plane. Line. Actually, I don't know how to title this this video on YouTube, because like I'm so used to calling it proof struggles, but we're not doing proofs in this one. So maybe I should like call it like baby mats. Maybe I should call it baby mats on the thumbnail. Instead of proof struggles, I'll probably put baby mats. Because technically, when you speak to a physicist or a mathematician, they probably consider this baby maths. Okay, so now we gotta take the vectors here. So 2, -5, and 2. That's the first vector. And the plane, we have 4, 1, -3. Okay, now we gotta actually do the cross product all over again. I mean, I'm glad I know how to do it. It's just writing it all the time is like very, very cumbersome sometimes. But that's the only way I know that I'm not getting stuff wrong. Because if I try to do it by memory, I know I'm gonna screw up somewhere. That's -2 here. And then I plus 2, 4 minus 2, -3. And then plus 2 times 4 k hat. Okay. Luckily, I have my calculator with me, so now I don't have to worry about. So that will be 15. So 15 minus 2. Yeah, I'm doing simple arithmetic with a calculator. It's just to make sure that I don't get stuff wrong. 2 times k plus 14 j plus 2 minus 5, -5 times 4, 22. Okay, so that's the vector we're dealing with here. Oh yeah, so we have to find the point of intersection. Yeah, find where the line intersects the plane. Okay, so we got that. So now just realized that I probably didn't need to. I probably didn't need to do the cross product to begin with. Okay, no problem, Grandma Ursula. Thank you for stopping by, and thank you for all the knowledge you just gave to us in the chat. Yeah, take care. And thank you for the follow. Okay. I probably did more work than I needed to, but at least I know how to take the cross product of like random amount of information that I was given. Terms. So I'm going to use my calculator for that one. So 8 plus 4 plus 9 is 21. And then we have 8 plus -5 plus -6. It's -3t. And we'll just move that over here. So 6. We get -15. And then do the division, we get, so in this case 5 is equal to, so that means if we have, so then x, so then that would be 12, and then y, it would be, is that a 5? Yeah, that's a 5. So 4 minus 25, that would be -21. Oop. -21, and then for z, so 10 plus 7. Hey Des, how's it going? What is this math? Sacrilege, I'm being numbers. I decided to basically go into like multivariable calculus because I've been slacking on that one. So I thought I would do some calculation based math just to get myself back into actually just doing like math techniques. Yeah, so that'll be -3, then yeah, that'll be fun. So okay, so we have -21, 12. So that would be here. Yes, that's correct. Cool. Calculus is the hardest math. Really? I thought real analysis was. Okay, here we go. Last question. Of this section anyway. So find, column 3, find the point. I actually didn't even need to write the cross product, but I ended up doing it anyway. At least I know how to do it though. Like with like a limited amount of information that was given to me, so. That's the thing with me. It's like whenever I think I'm being clever or something, I end up doing something that's completely unnecessary. Line. Then we have a plane, which is e to 5x. Yeah, this is not going to look nice. I know that for a fact. Okay, 55, 25t, 45, negative 63. No, that's not a plus. So negative 35. Negative 30t, 12. Okay, so negative 5 plus 49 plus negative 35, 41, negative 41, 25 plus 6, 63 I should say. Then that's negative 68t, 12, plus that, oops, not 14. Why am I writing 14? And then 5, 53. Oh, goody. This is going to be really fun. Do the hard maths here. This is negative. It's supposed to be negative in front. Almost forgot that little detail. Luckily my calculator is able to round it up for us. Or like make it into a fraction, I should say. I can't imagine what it was like to actually do it by hand. That would have been like very arduous. guess they've reduced it even more. But that's just strange. I see that the answer, the last part of the answer was not reduced. That's why it looks funny. So yeah, it equates to the same thing, but I think the person that wrote this problem didn't reduce it all the way. That's why it looks strange to me. So I think it's this one, because it looks like it's the closest one. Yes, and we got that correct. Nice. Okay, now we can continue on for this one. Okay, so now we're dealing with parallel, perpendicular, and angle between the planes. Okay, so parallel test. Use normal vectors to find the symmetry so if we have two normal vectors, then the symmetry between them would be like so. That's what we learned the last time. So that should help us. Now perpendicular. So the perpendicular test, just use the cross product. Perpendicular test. We'll just write this as vector A, vector B, so then vector A, vector B, and then for the angle, let's see, non-90 degree intersections. Use cosine. Okay, this seems like it's a bit straightforward. Usually with these tests, like it's usually the perpendicular and the intersection. That's usually when the test gets a little bit convoluted. Okay, so question 1. Say whether the planes are parallel or perpendicular, otherwise find the angle between them. Okay, so we got these two groups. So this is plane 1, and we got plane 2, like so. Right. Now, let's see if they're parallel first. Yep, I think they are, because it looks like each one of them are reduced to a half. So the first one, they are definitely parallel. Correct. Nice. Next question. Because I think I did not remember this concept, so I think I'm kind of glad that I'm doing this stream, because now I'm actually remembering what to do for you know, finding things that are parallel, and now basically doing the other stuff, which is like finding out if they're perpendicular and whatnot. Find the angle between them. Okay, so we got this plane and 2 plus 5, 7. So I don't think these will be as simple. I don't think these will be parallel. Yeah, they don't look like they're parallel. Yeah, they're definitely not parallel. So we're gonna have to do the other approach. So not parallel. So now let's see if they're perpendicular. 14 plus 30, then negative 10. So they're definitely not perpendicular. So that will leave us with negative 24. 24 plus 30. And that would just give us positive 6. So not perpendicular. So now we gotta just find the angle between them. So cosine of 6, because we needed the dot product of this one. And now we gotta have to have the magnitudes. So So 7 squared plus we'll just call it A, magnitude of A. So 49, 25 plus 4. We'll just write in their decimal forms. No need to be overcomplicated here. So this one's going to be 4 plus 36 plus 25. Okay, so then we got to take the cosine inverse, then multiply this times this, which gives us 85.2 degrees. And that's one of the answers. Cool. So we got that one right. Now, the last one. I think we'll end stream there. So it's going to be the same scenario. So I don't think we have to rewrite the question because it's saying the same thing. So plus 1. So let's check if they're parallel first. So negative 2, 3. No, I don't think they're parallel because it's the way they look. Yep. So it's not parallel. So now let's do the cross product. Plus 5. That leaves us with 8. Negative 8. Plus 3 plus 5. That leaves us with 0. So they are perpendicular. I just realized I spelled perpendicular wrong. Just double checking my math just to make sure that I am not. So yeah, that's negative 2, right? Yeah, that looks correct the way it looks. Yeah, so they are perpendicular, so I don't think we have to do anything else with that. Yep, we got it correct. Nice. Okay, so we managed to do a few sections of multivariable calculus, and that felt like it was a very productive stream with that because how many sections we went through? I think we went through like just 2 or 3. So we did parallel, intersection, skewed lines. So we had an equation of a plane. So that was, and then, okay, so we did 3 sections. That's actually pretty good. Okay, that's pretty good. I'm actually happy about that. So I think we'll probably continue on with more multivariable calculus because it felt like I like a lot of stuff there. Okay guys, thanks for joining me today. If you're actually tuning for the stream for the first time and you like math and physics, you know, drop a follow. It really keeps motivating me to make more streams and studying more math with you guys, as well as physics as well, because some of you guys are also into physics. So I will probably try to get back into like doing some physics problems soon too. And if you guys are watching this on YouTube, you know, be sure to hit the like, comment, and subscribe if you want to catch more math and physics content on the channel. And for all those that are on Twitch, I will post up all the links to all the things of the social medias, mainly my YouTube channel. For all those that are watching on YouTube, all the links will be in the description down below, to the Discord, and also to my Uncle Talks channel if you want to watch my streams of when I play video games. You know, that's when I'm actually not doing like math stuff. Okay guys, I think that will do it for today, and thank you for joining me on this, I guess, baby maths session. So always remember guys, everyone is precious. You guys are just as precious as everyone else, and I will see you guys in the next stream. So take care guys. Bye-bye.